Welcome back. Today we will be talking about the arithmetic sequence. We have discussed the difference between sequence and series in the last video. So arithmetic sequence, we are talking about the common difference between the two consecutive terms of the sequence. Consecutive implies one after another. So this formula an, that means any n term, n is an integer, will be considered if I have the first term, the common difference, and then I can use this formula. So this formula will help you to find the another term. For example, if you have three terms and you need to find the fourth term, or maybe the 20th term, the 100th term, then this setting will really help you. So in this example, that common difference is 3, and the first term is the fifth term. Now, if I need to generate the formula for this particular question, I'm starting with a basic one. That means the first term plus n minus 1 times the common difference. If I plug all the given values that I have, so n, I don't know yet, so n minus 1 times the common difference. If you simplify it algebraically, you will get the equation as 3n plus 2. So if I use this equation 3n plus 2, and if you have to find out any term, maybe a 20th term or the 30th term for this particular question, then it will be easier for you. So remember, this particular setup is useful for finding the next terms. In this case, we don't know the first term, but we know the fourth term and the 13th term, and they want the first 7 terms of the sequence. So the first thing is, what is the difference between 4 and 13th? So we are covering the distance of 9 terms. Now, if I take the difference between the value of 13th term and the value of the fourth term, I will get, it should be A4, it should be 45. So between the value, the distance between fourth and the 13th term is of 9, and we have the total value as 45. So 45 divided by 9, that means we are looking for a common difference of 5. Again, the difference between the value will be divided by the distance. So if I have to find the third term, it will be 15 because the common difference is 5. A2 will be 10, A1 will be 5. If I have to calculate A5 will be 25. A6, again 5 more will be 30, and so on. Right? So remember, find the difference between the values and the total distance and divide. Now this question is a little bit interesting because in this one, they are saying find the 9th term of the arithmetic sequence that begins with 2 and 9. So they have not specifically mentioned what do you mean by the first two terms. So what they want to imply that A1 and A2. So A1 and A2 is given. And if you look at the difference between A1 and A2, the common difference is of 7. And I can use my setup to find the another term. An is equal to the first term plus n minus 1 times the common difference. And we are looking for the 9th term. So n in this case is 9. So if I use the same format, you will get the lovely answer as 58. Now we talked about the terms, how to get the next term. To combine the terms together, that is a sum of the finite arithmetic sequence. To get the sum, that means summation of the finite sequence, we look for the average, you can say the average of the first term and the last term times the number of terms we are talking about. In case if we have to find the sum of the infinite sequence, then we use the partial sum. Partial sum we have discussed in the last video. Partial sum is nothing but instead of finding the value to infinity, we define, oh, I don't want infinity, I need the till 50th term or the 30th term or whatsoever. So let's start with first example and let's take the case of the finite. So in this case, they want the sum of the integers from 1 to 100. So we have A1 and A9. So I want the summation of the first 100 terms. So S100, number of terms are 100. So N is 100. And we have the first term as 1 and the 100th or the last term, AN, is 100. So N is the integer, right? So in this case, the last term is the 100. So N is 100. So if I take the average of the first and the last term, and then times with number of terms we are talking about, you will get the sum of the integers. So this is quite handy. Instead of adding all the numbers from 1 to 100, which is not possible in all the scenarios, then this formula comes really handy. So you can pause the video and try on your own what will be the summation of 1 to 35. And let's move on. What will happen if we have an infinite series? For the infinite series, infinite sequence, when they are talking about the 1/20th partial sum. By I said series is the summation. So we are talking about the summation in this case. So in this particular problem, we know that A1 is 6 and A2 is 12 and so on. So I can find the common difference. The common pattern or the common difference between the first two terms is 6. And if I follow the A third, and A third is also every time we are adding 6. Now, we want 1/20th partial sum. That means this is the case of an infinite because dot 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 is there after 30. But we are cutting the chase by saying, okay, let's count till, find the sum till 1/20th term. So A1, I need to find what is A120. For that, I need to go and find the term. To get the term, we are using the previous formula AN plus n minus 1 times D. So A1 is 6, we want 1/20th term. So 120 minus 1 times 6, you can distribute it. You will get 720 minus 6. And 6 and 6 can cancel out. So A120, that means the 1/20th term has the value of 720. Now they want the partial sum for the 1/20th term. That means I have the first term, which is 6, and the last term that we want to calculate the summation of is 720. So we can find the sum of 120, summation of 120. N is 120 because the 1/20th term. So 120 divided by 2, sum of the first and sum of the last. And if you calculate it, you will get 60 times 726, multiply the 2, you will get your answer. Now, we started with the summation of the infinite, but we wanted the partial sum.